Balancing redox equations using the half reaction method. Put the oxidation number or charges on each element. So the little numbers up at the top right hand corner are the oxidation numbers. Those are the charges of each of the elements. Look at the charges on each element and find the ones that increase or decrease. If the charge remains the same, leave it be. If it increases, it's oxidized. If it decreases, it's reduced. In the equation above, sulfur's charge goes from 0 to +4, which means it's oxidized. Hydrogen and oxygen charges stay the same, so you leave them alone. Nitrogen decreases from +5 to +2, so it's being reduced. The oxidation half reaction is S equals SO2. You have to write the whole compound, not just S, because it's together with oxygen. The reduction half reaction is HNO3 equals NO. Write down the whole compound, not just N. Now we have to balance atoms other than O and H. The oxidation half reaction, S equals SO2. There is one atom of S for each, but there are 2 oxygen atoms on the product side and not on the reactant side. We have to add 2 oxygens to balance it out. The rule is add H2O to balance O and H plus to balance H. Add 2 molecules of H2O because we want 2 oxygen atoms, not 1. Now we have hydrogen on the reactant side, but not on the product, so we have to add hydrogen to that side. We need 4 hydrogen atoms to balance out the equation. So we add 4 hydrogen atoms on that side, and it's balanced. We do the same process for the reduction half reaction. HNO3 equals NO2. Here we see that H and O are not equal. You can add 2 molecules of H2O to the product side to balance oxygen. The oxygen is balanced, but not the hydrogen. You need to add 3 more hydrogen to the reactant side to balance hydrogen. Now the equation is balanced.
Okay, for step 6, you have to count the total charge of the reactants and for the products. Here's the oxidation half reaction. You need to know the charge to get the total charge. Here you have 4 hydrogen atoms, and each hydrogen atom has a +1 charge. So 2 times 2 is 4, and you bring that down here. And oxygen has a -2 charge, and there are 2 atoms of oxygen atoms. So 2 times -2 is -4, and sulfur is 0. So if you add 0 here, it will give you 0. So the total charge on the reactant side is 0. Here is the product side. There's 4 charge of sulfur and -4 charge of oxygen, and you bring that down here, and 4 charge of hydrogen, and if you add them together you get 4. Here's the reduction half reaction. There's a 3 charge on hydrogen, and here you just add them. 1 plus 5 is 6, and 3 times -2 is -6. And you just have to add them. 3 plus 6 is 9, 9 minus 6 is 3. Over here, you bring down the charges and you add them, and you get 0. Step 7. After you get the total charge, notice the charges aren't equal. We have to make them equal to 0 for both sides, and you do this by adding the required amount of electrons to make it 0. Oxidation half reaction. The total charge on the reactant side is 0, and the total charge on the product side is 4. You have to get this to 0 by adding 4 electrons. Reduction half reaction. The total charge on the reactant side is 3, and the total charge on the product side is 0. You have to get this to 0 by adding 3 electrons. Step 8. Now we have an unequal amount of electrons. One has 4 electrons while the other has 3. It has to be equal. And you do that by multiplying the whole equation to get the least common multiple of 3 and 4. In this case, 12 is the least common multiple. Oxidation half reaction. This is the equation for the oxidation half reaction. To get 12 electrons, you multiply it by 3. So 3 times 2 is 6, 3 times 1 is 3, 3 times, and so on. And you do the same for reduction half reaction. You multiply it by 4 to get 12 electrons. 4 times 3 is 12, 4 times 1 is 4, and so on. Now we have 12 electrons for both equations. The last step is to add the two half reactions together. The oxidation reaction equation is this, and the reduction is this. Now write all reactants on the reactant side and write all the products on the product side. This is the reactant side, so copy it down. 6H2O, 3S plus 12H plus 4HNO3 and plus 12 electrons. And do the same for the product side. Bring down 3SO2 here, 12H, 12 electrons, 4NO, 8H2O. The last step is to cancel all the stuff that appears on both sides of the arrow. For example, we have 12H here and 12H here, so you can cancel that out. And we have 12 electrons here and 12 electrons here, and cancel that out too. Here we have H2O and H2O. Cancel it out and you're left with 2H2O because 8 minus 6 is 2H2O. And your final equation will look like this. 3S plus 4HNO3 and 3SO2, 4NO, and 2H2O.